So hello students, now this is the Venkatayadagiri chemistry classes. Now today concept is that dipole moment. Okay. Now here dipole moment symbol is the mu. So what is the use of this dipole moment? Dipole moment measures the polarity of a covalent molecule. Whether the molecule has the polarity or not, whether the molecule has the charge or not. Okay. It measures the polarity of the molecule. Next. So the dipole moment symbol is the mu. Its formula is that delta into L. Sir, what is the meaning of delta? Delta is the magnitude of charge of any one pole. Magnitude of charge of any one pole. Now here, for example, if we take the polar covalent molecule HCl, polar covalent molecule HCl. Here, hydrogen and chlorine. Chlorine has more electronegativity, therefore the bond pair of electrons are more nearer to the chlorine. The bond pair of electrons are more nearer to the chlorine. When bond pair of electrons are more near to the chlorine, this chlorine gets partial negative charge and hydrogen gets partial positive charge. Right? Now this plus and minus, these two called as a charges. Okay, that is nothing but a poles. Now here the plus 1 and it is a minus 1. So what is the magnitude of this charge? 1 unit. It's the magnitude of the charge is nothing but a 1 unit. So magnitude of charge of any one pole and distance between the two poles. Distance between the two poles is called as a length, or we can write this L is equal to length, or we can write distance between the two poles is nothing but a L. Now, dipole moment definition is that delta into L. This is the formula. So, here the into means product. The product of magnitude of charge of any one pole and distance between two poles is called as a dipole moment. Clear? Okay. Okay, students. Now, definition of the dipole moment is completed. Okay. After this one, come to the third point is that units of the dipole moment. Units of the dipole moment is the dBi, and another unit is the ESU centimeter, and third one is that Coulomb meter. Now dipole moment formula is that delta into L. Delta is called as a charge and L is nothing but a length. So charge unit is the ESU, electrostatic unit, and length unit is the centimeter. Right? Next one is that charge unit is the Coulomb and length unit is the meter. You know that one centimeter is the unit in length unit in CGS. So ESU centimeter, it is the dipole moment unit in CGS, and the Coulomb meter is nothing but a in SI. Coulomb symbol is the C and meter symbol is the M. Okay. Now here, 1 dBi is equal to 1.0 into 10 power minus 18 ESU centimeter, and 1 dBi is equal to 3.33 into 10 power minus 30 Coulomb meters. Okay. Is ESU centimeter, it is CGS, and Coulomb meter, it is in SI. Now, dipole moment of a single covalent bond. Dipole moment of a single covalent bond, not a total molecule, it is a single covalent bond. Dipole moment of a single covalent bond is called as a bond moment. Bond moment. Clear? Okay. Okay, students. Now, dipole moment is a vector quantity. Dipole moment is a vector quantity. It has a positive value in one direction and a negative value in an opposite direction. So, dipole moment is a vector quantity. It has a positive value in one direction and a negative value in opposite direction. Next point. If a dipole moment is equal to 0, if a molecule dipole moment is equal to 0, then that molecule is a non-polar molecule. Charges are not present and that molecule is a symmetric molecule. Now here the example, if we say, if you go to the example, beryllium chloride, BeCl2. So beryllium is the central atom and chlorine and chlorine. Between the beryllium and chlorine, chlorine has the more electronegativity. Therefore, the shared pair of electrons or bond moment is going towards the, that is the right side. Let us, this bond moment towards the right side, it is a positive value. And again, beryllium and chlorine. Chlorine has the more, therefore, the bond moment is going towards the chlorine side. Simple bond moments means the shared pair of electrons are moving towards the more electronegative atom, right? So this is the positive one, it is a negative. Next, sum of the total bond moments is nothing but a dipole moment for the BeCl2 is equal to 0. When dipole moment is equal to 0, this beryllium chloride molecule is non-polar and symmetric molecule. Clear? Next, example CO2, carbon dioxide. Here, carbon, double bond O, double bond O. Between the carbon and oxygen, oxygen has the more electronegativity, therefore the bond moment is going towards the right hand side. Right side is the positive value, left side is a negative value. Therefore, sum is equal to 0. In the same sense, carbon disulfide, CS2. The name of the CS2 is called as carbon disulfide. Now, it is also similar to the CO2 molecule. Now, here also dipole moment is equal to 0. Ultimately, it is a non-polar and symmetric molecule. Okay. Right, okay students. Now here in dipole moment, another example is that boron trichloride, BCl3. In BCl3, boron is the central atom, chlorine. Now the molecular shape is the trigonal planar. In this one, dipole moment, so boron and chlorine has the more dipole moment, it is going towards the right hand side, and this right side dipole moment is equal to the sum of the dipole moments of these two. Means that, let us this value, magnitude is the 4 and this magnitude is the 2, this magnitude is the 2. So, 2 plus 2, sum of these two dipole moments is equal to this one. So, net dipole moment is nothing but a 0. Let us, this is the positive 4, it is a negative 2, it is a negative 2, minus 2. Then minus 2 plus minus 2, minus 4 plus positive 4 is equal to 0. Next, in the same sense, carbon tetrachloride. In carbon tetrachloride, carbon is nothing but a central atom. Now, chlorine, right? Now, between the carbon and chlorine has the more electronegativity. Therefore, bond moment is going towards upside. So, let us, upside is the positive, downside is the negative, net dipole moment is 0. Next, come to the carbon chlorine. Right side chlorine positive, left side chlorine is a negative. Net is a 0. So, mu is equal to 0. The next one is that different examples, PCl5, phosphorus pentachloride, sulfur hexafluoride, BeCl2, BCl3, CO2, CS2, IF7. Like the molecules have the zero dipole moment. When they have the zero dipole moment, they are the non-polar and symmetric molecule. They are the what? Non-polar and symmetric molecule. Right. Now, if dipole moment is not equal to 0, means that dipole moment is equal to 0 means dipole moment is not present. But here dipole moment is not equal to 0 means dipole moment is present. If the dipole moment is present, then the molecule is a polar and asymmetric one. Then the molecule is polar, asymmetric one. Now, here the chloroform. Chloroform is the best example for the understanding for the dipole moment. For the polar molecule, CHCl3 chloroform. Central atom is the carbon. Let us, I am writing the two chlorines, right side and left side. Now, let us, carbon and chlorine. Chlorine has the more electronegativity, therefore bond moment is going towards the right hand side, positive value. Left hand side, negative. So, sum is the 0. Next, come to the carbon to hydrogen, carbon to chlorine. Carbon to chlorine, chlorine has more electronegativity, therefore bond moment is coming down. Let us, it is a negative. Next, hydrogen and carbon. So, carbon has more electronegativity, again bond moment is coming down, therefore it is a negative. Negative plus negative value, somewhat the dipole moment is present. So, mu is not equal to 0. When mu is not equal to 0 or mu is present, then that molecule is a polar. Next, come to the ammonia. This ammonia contains the lone pair of electron. Generally, if the lone pair of electron, if the single lone pair is present, 100% that is a polar. So, ammonia, nitrogen, 3 hydrogen, between the nitrogen and hydrogen, nitrogen has the more electronegativity, therefore the bond moments are going the upside in one direction. This lone pair is also going in up. So net dipole moment is not equal to 0, means it has the dipole moment, therefore it is a polar. Next, come to the water. Water is also polar because lone pair of electron is present, and this RNH2 is called as a primary amine. Here the nitrogen has the lone pair of electrons. Clear? Okay, students. Now here the another condition is that if mu is equal to 0, if mu is equal to 0 means dipole moment is equal to 0, then molecule is a non-polar and symmetric molecule. Okay, already you know that one. We learned. If the dipole moment is present, that is a polar and unsymmetric. Now here the dipole moment is not present, therefore it is a non-polar and symmetric. Example: CH4, methane, carbon tetrachloride, beryllium dichloride, carbon dioxide, carbon disulfide, sulfur hexafluoride, iodine heptafluoride. Next one is the phosphorus pentachloride. Next. Now here this point is very important for the shortcut. So what is the necessary condition to exhibit the zero dipole moment? For zero dipole moment, now lone pair of electrons should be 0. To exhibit the zero dipole moment, lone pair of electrons should be 0. First condition. The second condition is that central atom should be surrounded by identical atoms or groups. Okay, lone pair should be the 0 and central atom should be surrounded by the identical atoms. Then the dipole moment is equal to 0. Means zero dipole moment, that is a non-polar. Here for example, if we take the CH4 methane, 0 lone pair, no doubt. So carbon is the central atom. Around that carbon, 4 identical groups should be present. Therefore, 0 lone pair, 4 identical groups are present. Therefore, 100% dipole moment is equal to 0. It is a non-polar. It is a shortcut. Next, for example, chloroform. In chloroform, no doubt, lone pair of electrons is equal to 0. But around the central atom carbon, so not all are the similar groups, identical groups. See, out of here, chlorine, chlorine, chlorine. 3 chlorines are identical, but fourth one is the different. Therefore, this is 100%. It has dipole moment and it is a polar. Clear, beta? Okay, students. Okay, students. Now, here if the lone pair of electrons are the 0, then dipole moment may be 0. Lone pair of electrons 0 and the central atom should be surrounded by the identical atoms. Next, another one is that here, if the lone pair of electrons are present, on central atom, then 100% that has the dipole moment. So, ammonia, a nitrogen has the lone pair, water, 2 lone pairs, alcohol, lone pair, therefore it is a polar, dipole moment is present. If the dipole moment is present, 100% that is the molecule is a polar, asymmetric molecule. Now here the ROR, ether, oxygen has the 2 lone pairs, RNH2, primary amine, 1 lone pair, RNHR, this is the secondary amine, 1 lone pair, 100% it is a polar. Next, tertiary amine, so 3-degree amine has the 1 lone pair. So all have the lone pair of electrons, right? So if the lone pair of electrons are present, that molecule is what? That's a polar, and dipole moment is present, polar and asymmetric one. Now I said that one. So lone pair, if the lone pair of electrons are not present, then whether it is a polar or non-polar means that based on the condition. So if the lone pair of electrons are the 0, if the central atom is surrounded by the identical atoms, then that is a non-polar. If the non-identical groups are present, that is a polar. Clear? But xenon tetrafluoride and xenon difluoride, okay, xenon tetrafluoride but xenon difluorides are non-polar, symmetric. Non-polar, symmetric means mu is equal to 0 even though with with lone pair of electrons. Okay na? Fine. Lone pair of electrons ఉన్న నీ కొరకే చెప్తాను ఇక్కడ కూర్చో. Okay students, generally if the lone pair of electrons are present, that is a polar. If the lone pair of electrons are present, that is a polar. But here the two cases are present. So example is that xenon difluorides and xenon tetrafluoride. This question was asked in one time in IIT and as well as in NEET. So which of the following has the zero dipole moment? Which of the following is the non-polar and symmetric? He asked that. So xenon tetrafluoride, xenon difluoride are zero dipole moment even though with a lone pair of electrons. So why they have the zero dipole moment? That is the question. So if you see the structure, xenon tetrafluoride, this is a square planar geometry. Now this fluorine bond moment is cancelled. This fluorine and this fluorine bond moment is cancelled. Next, lone pairs. One is the above the plane and second one is the below the plane. This lone pair moment upside, this lone pair moment is downside. So both are the cancelled. Then mu is equal to 0. Then if the dipole moment is equal to 0 or zero dipole moment, non-polar and symmetric one. Now come to the xenon difluoride. Here also one fluorine is upside, another fluorine is down. So this moment is the positive, this moment is the negative. Net dipole moment is 0. Next, lone pairs in a xenon difluoride, 3 lone pairs are present. They are present on, that is nothing but a trigonal planar structure. They are present equatorially. This lone pair moment is equal to the sum of these 2 lone pairs. Therefore, dipole moment is equal to 0. When zero dipole moment, that molecule is the non-polar and symmetric one. Okay, but right. So this is about the dipole moment. So lesson topic 1, and we'll continue in next class lesson number, that is topic 2 of this dipole moment continuation, and we'll try to complete that one and we'll do the numericals in next class. Okay.